Howdy. I just stumbled some time ago about an article which I found very interesting. I made 2 months ago a video where I ask, do cryptodomes degas by releasing hydrogen? And that's just one of the more than 300 videos I made about the topic mountain water, wide rivers and such things. So let's just take a look at the article or scientific paper. I stumbled across this on phys.org and it was released 13 hours ago. Ice cores show even dormant volcanoes leak abundant sulfur into the atmosphere. And if you scroll down here, you can click on this link and they will bring you to the paper. Advancing Earth and Space Science. AGU. Geophysical Research Letters, Volume 50, Issue 1. Open Access. Underestimated passive volcanic sulfur degassing implies overestimated anthropogenic aerosol forcing. In other words, they are surprised how much more sulfur and stuff is coming out of the volcanoes. It's much more than previously thought and implies overestimated anthropogenic aerosol forcing means that human-made pollution or releasing of these gases is overestimated. Anthropogenic means human-made. This is what this means. This is basically a very good paper against common climate talk like everybody's talking about climate change. Don't drive your car anymore and shut up because you're breathing out 400 times more CO2 than breathing in. You are destroying the world with breathing, which is total crap. Nature doesn't work like that. But anyway, I won't make a whole read through because it's a rather long article. But let's read quickly the abstract. The Arctic is warming at almost 4 times the global rate at an estimated 60%, and greenhouse gas-induced Arctic warming has been offset by anthropogenic aerosols, human-made anthropogenic. But the contribution of aerosols to radiative forcing represents the largest uncertainty in estimating total radiative forcing, RF, largely due to unknown pre-industrial aerosol abundance. Yeah, how you can compare if you don't know what to compare to. Here, sulfur isotope measurements in the Greenland ice core show that passive volcanic degassing contributes up to 60 plus minus 10% of pre-industrial ice core sulfur in years without major eruptions. And if you think about that Earth is tilting over back and forth every now and then, you have to assume that where we have ice now at the polar caps, there won't be probably any ice in the times where the polar cap is at the equator. So it will melt and freeze again. And it might be in a different place as well. But anyway, a state-of-the-art model indicates passive volcanic sulfur emissions influencing the Arctic are underestimated by up to a factor of 3. So it could be 3 times more. Possibly because many volcanic inventories do not include hydrogen sulfide emissions. Hydrogen. I cannot zoom in, I try to zoom in. Hydrogen mixed with sulfide. Higher pre-industrial volcanic sulfur emissions reduce modeled anthropogenic Arctic aerosols cooling by up to a factor of 0.1 to 0.29 watts per square meter, maybe. I don't know. Anyway, 3 times more, suggesting that underestimating passive volcanic sulfur emissions has significant implications for anthropogenic-induced Arctic climate change. They basically admit that there are big problems with the climate models they use nowadays to control the population. Anyway, key points. Sulfur isotopes in the Greenland ice core show that passive volcanic degassing contributes 66% of pre-industrial Arctic sulfide. The volcanic inventory used by most climate models underestimates passive degassing, possibly due to emission. No, I'm not in reading mode. Maybe you notice I have so many other things in my mind. Possibly due to missing hydrogen sulfide emissions. Hydrogen. Elevated pre-industrial passive volcanic degassing reduces the estimated cooling effect of anthropogenic sulfide in the Arctic. Reduces the estimated cooling effect of anthropogenic sulfide in the Arctic. So the influence of humans is much smaller than previously thought. And they are talking about, I think it's Iceland mainly. Now let's try. Maybe I get in the reading mode. Stop thinking, just read. Plain language summary. Sulfide aerosols are particles in the atmosphere that have a net cooling effect on the climate. One of the most uncertain aspects of climate modeling is the abundance of sulfide aerosols during the pre-industrial era. Without knowing the amount of sulfide aerosols during the pre-industrial, it is difficult to estimate how much anthropogenic sulfide aerosols have offset warming from anthropogenic greenhouse gases. Yes. In this study, we examined pre-industrial sulfide aerosols in the Greenland ice core. We find that sulfide aerosols from passive, i.e. non-eruptive volcanic degassing contribute almost 2/3 of pre-industrial Arctic sulfide aerosols in years without major volcanic eruptions. We compare this result to a state-of-the-art global model and find that most climate models use a volcanic emissions inventory that underestimates pre-industrial passive volcanic sulfur emissions. The volcanic inventory only includes one type of sulfur emission, sulfur dioxide, but studies have shown that volcanoes emit hydrogen sulfide, which can also form sulfide aerosols. We show that higher emissions of volcanic sulfur during the pre-industrial era decrease the estimated cooling effect of anthropogenic aerosols during the industrial era. Decrease the estimated cooling effect of anthropogenic aerosols during the industrial era. Thus, the underestimate of pre-industrial volcanic emissions in current climate models has significant implications for anthropogenic climate change in the Arctic. Yes, I will put a link below, but I think that's a very, very, very interesting article. Not only it mentions hydrogen emissions from volcanoes, this time mixed with sulfur. It does also somehow put a correction to the common assumption of that your car and your breathing and our industrial life does have such a big influence, since obviously it doesn't. Very interesting, very interesting. But I will leave it here. I will put links below to this. And I think that's quite fresh, 2nd of January. But anyway, thanks. Bye.